Everybody, welcome to Math with ACE. Focusing on statistics and hypothesis testing today. We're going to get into the very basics of hypothesis testing and a general idea before we go into the specific parts and requirements. Hypothesis testing is an inference procedure that is done in statistics where we take sample data and we use that sample data to make a generalization about the population. And like confidence intervals, we have this process that we go through. The difference between hypothesis testing and confidence intervals is that we use a confidence interval to estimate some value about the population, some parameter. For example, if I want to know the average age of people who watch, let's say, K-pop Demon Hunters. Or what if I want to know the true percentage of people who are in favor of voting for a particular candidate in an election? We would gather a sample and we would collect data from that sample, and then we would analyze the data and use that to make a generalization about the population. Hypothesis testing is not where we want to estimate something about a population, but we want to test a claim that we have. So for example, let's say I tell my students that the average test score was a 90. And my students say, we don't believe you. We think it's less than that. That's a claim that we could then test by gathering sample data. We would look at test scores and we would calculate a test statistic from that. So calculate the average of those samples. And then we would see how likely that is, assuming that the null was 90, like assuming that what I'm saying is true. And we would calculate a test statistic based on distributions that we've been working with. So a normal distribution or a t-distribution and how likely that is. And that probability will tell us whether there's evidence for the claim or not. So that's the idea behind a hypothesis test. It's really important that you collect data appropriately so that you can make generalizations to the population, try to eliminate bias. We have to make sure that we have conditions that are met in terms of sampling small in relation to your population, and that we are able to calculate probabilities from a t-distribution or a normal distribution based on whether successes and failures are at least 10, or if you're, by the central limit theorem, if your sample was 30 for means. So there's all these things that we have to consider when we are doing hypothesis testing. But the main thing is you have a claim that you're testing, and that comes from the problem. You have a significance level. Now, your significance level, it's basically this baseline for how strong do we want our evidence to be, or how small do we want our probability to be in order to say we have evidence or not. So we need to have the claim, we need this level of significance, we need to collect our data, meeting our conditions, and then we'll calculate a test statistic. Now, just to show you what we're talking about with this test statistic, you're typically using either a z-score for proportions or a t-score for means. So hypothesis testing, just like confidence intervals, focuses typically on averages and percents. And we very often do not know the standard deviation of the population. So we use a t-distribution. You can see back previous videos on that one. Proportions will use a z-distribution. You have some hypothesized value from the problem. So for my example, my test score, I said it was 90. And then based on the standard deviation of the sample and the average of the sample, we use that to calculate a test statistic. So let's say maybe my standard deviation of the sample was 2, and my sample size was 25. And my average was, let's say, 87. What we can then do is calculate the standard deviation or the standard error based on the standard deviation of the sample. So we could take the standard error of the sampling distribution and take our standard deviation of the sample divided by the square root of n. So 2 divided by the square root of 25, which is 0.4. And then we know that we can label our distribution using, let's say, the empirical rule. So 90.4, 90.8, 91.2, or 89.6, 89.2, or 88.8. Now, the sample mean that I got was 87, which is over here. And based on the way that I've drawn this picture, you should understand that typically 95% live within about 2 standard deviations. And I'm away, I'm more than 3 standard deviations away. So my test statistic is going to be negative because it's the sample mean is below average that we're hypothesizing. And it's going to be more than 3 because it is further than 3 standard deviations. So your test statistic is how many standard deviations from the mean you are. It's that probability. This probability of occurring, if you recall normal distributions and t-distributions, that's very unlikely. And so what's happening is this value of 90 seems, if we got 87, it seems pretty unlikely that 90 really is the true average. And so what that means is we have evidence for the claim of the students saying that they think that the test score is less. Okay. In our next video, we're going to learn how to set up null and alternative hypotheses, whether we're talking about a one-tailed or a two-tailed test, different directions, and what that looks like. So stick around for our next video.